Hello, this is Captain Ross with 3B's Captain School, and this video is piloting in our navigation video series. Navigation, the art and science of directing the movements of a vessel safely, confidently, and efficiently from one location to another. All right, this video we're going to discuss piloting. We're going to go over or be able to state the definitions of important piloting terms, state the basic piloting tools and their uses, define the basic elements of plotting tools, solve for time, speed, and distance problems, solve adding and subtracting military time. All right, piloting terms. First we'll go over its bearing. Bearing is the horizontal direction of one terrestrial point from another, is expressed as the angular distance in degrees. So the bearing from point A to point B on our chart and on our compass, we're going to express it in bearing in degrees. We're going to express that bearing in degrees. So it's going to be 90 degrees from point A to point B. And that can be 90 degrees true, 90 degrees magnetic, or 90 degrees compass. And we've discussed that in the previous video. Course, intended horizontal direction of travel. Heading is the actual direction the boat's bow is pointing. So you can have your bow pointing in one direction and be slightly off that for the actual course that you're going over ground due to current. You've got your bow into the current or to the wind. So heading and course are a little bit different. And then dead reckoning, which is our next definition, is the determination of approximate position by advancing a previous position for course and distance without regard to set and drift. So what does that look like? If you look at the chart over here, if I was starting in this position X that I just clicked on there, I'll kind of take my cursor over it right here, and drew a track line of the direction I wanted to go. Let's say this is 005 degrees true. I would know as I'm on my course that I'm on this line somewhere. So if I took that course and let's say I left at 10 o'clock from this position, and then at 10:10 I wanted to know where I was at, I could take my speed in that 10-minute time from 10 to 10:10 and determine how far along this line I should be. That's a time, speed, distance problem. So you see this little half circle with this little point. Using dead reckoning, if I left here at 10 o'clock and I was doing, let's say, 6 knots, then at minute 10 or 10 minutes after I left, I should be 1 nautical mile from the point I left. And then if I did another 10 minutes, I should be another nautical mile from my 10:10 point. So dead reckoning, I leave a known point, which is this X, at a time on a certain course, which this one is 005, at a speed, which in this case is 6 knots. So I should be 1 nautical mile along that line at 10 minutes, 2 nautical miles along that line at 20 minutes. That's dead reckoning. Position is our actual geographic location of the boat. ETA is our estimated time of arrival. A nautical mile is 2,000 yards, it's a mile on the water. So it's nautical, it's a mile on the water. Knots is a unit of speed equal to 1 nautical mile per hour. So on land, we're all very used to saying miles per hour. We're talking about statute miles when we're on land. When we're on the water, we're talking about nautical miles, which are a little bit farther, about 6,000 feet or 2,000 yards instead of 5,240 feet or whatever a statute mile is. So a knot is just a nautical mile per hour. So if I said I'm doing 10 knots, I'm doing 10 nautical miles per hour. Set is a direction towards which the current is flowing, and we express that in true. Drift is the speed of the current, usually stated in knots. Remember, knot is a nautical mile per hour. Course over ground, course made good, is the actual direction course of movement from one point to another. Speed over ground, speed made good is actual speed, and knots over ground or made good. Okay, let's go over some basic piloting equipment or plotting tools. Parallel rulers. These are two rulers connected by metal straps to keep them parallel. Parallels are used to transfer the bearing to and from the compass rose and to draw a straight line on the chart. So here's a picture of a set of parallel rulers from Weems and Plath, and you can see where they're connected by these metal straps here. There's the one ruler and the second ruler, and then they have these little cork pads on the bottom that help it move across a chart. So you basically hold one side while you move the other, and then you just move the second side back to the first one to catch up to it, and you can move it all the way across the chart. This is a line diagram of a set of parallel rulers that are opened, and they're going across a compass rose here. And you can see where the top of this thing is at a course of 0.68, and the bottom, each of these lines are exactly parallel. So every one of these lines is measuring, in this case, 68 degrees of bearing. Let's take a quick look at some parallel rules being used here. So I've got them lined up on the compass rose at 0, 0, 0. Now I'm just going to move that left ruler over to the Chesapeake light. Now I've got a straight edge to draw a line at that 0, 0, 0 degrees true course. If you look over on the upper left-hand corner by my hand there, you can see a set and drift problem I was working. So I can line the parallel rulers up on that set line and then move them down to my compass rose one at a time and get the course for that set. So dividers are two pointed legs hinged at the upper ends where they join. These are used to measure distance or lat and long on a chart. When you add a pencil lead to one of the pointed ends, that same instrument is referred to as a compass. It's basically the same instrument though. Compass with a pencil lead, dividers with 2 points. If you look at this diagram here, you can see the corner of a chart, and they've got the dividers out here measuring distance. So the first thing they did was they went to the latitude scale and they set the dividers up at 1 nautical mile. And remember, latitudes are parallel, so 1 minute of latitude equals 1 nautical mile. And then they placed the point at the beginning of the track line, measured a mile, turned the dividers over, flipped them around while this point right here stayed in place, measured the second nautical mile, then measured the third nautical mile. This is Captain Ross, and this concludes our video on piloting terms and plotting tools. Please check our YouTube channel for other videos.